In this video, we'll take a look at how values are represented in Swift. So I've got a blank playground open here in Xcode 7, and I'm going to, at the top, import the foundation module. Now don't worry if this doesn't make sense at the moment. All it's going to do is let the playground have access to some standard library code that performs common tasks. We'll learn more about modules later on. One of the types of values supported by Swift is a variable. And a variable is a value that can change. To create one, you simply use the var keyword. Now if you've used other languages with a var keyword, forget what you know because Swift is rather strict about the usage. In fact, every time you create a variable, you must use the var keyword. After the var keyword comes the name of the variable. And I'm going to call this one message, and then put a colon and then a type annotation. So I'll use this to make the message variable a string. Now I can initialize the variable with a value, and I'll just use the canonical hello world. Clean up this extra space, and you can see that the playground has automatically executed this code for me and showed me the result, which is the string hello world, in the right side of the playground. Now if I want to use the variable elsewhere, I can refer to it by its name. So on the next line I could change the value to something like hi there. And again, the playground will execute the code and show that the value is now hi there. Since the variable was previously declared, I don't have to use the var keyword again when changing the value, and in fact if I tried to, I'm going to get an error. So if I click on this marker here for the error, it's going to give me some details over here and say that the invalid redeclaration of message, which means that I'm trying to declare a variable called message when a variable called message already exists. And that's just one way to create a variable. But there's more. When I created this variable message up here, I was explicit about the type of the message. However, Swift also supports type inference. Thus, Swift can infer the type of a variable from its value. So I can remove the type annotation and the colon, and if I remove this second var keyword down here, you'll see that the code still works the same. Since hello world is a string, message will be inferred to be a string. Now, this does not exempt message from other typing rules. Regardless of if the type of a value is explicitly declared or if it is inferred, the type cannot change. The type of a value will always be the same as the type when it is initialized. So let's explore this. First of all, I'm going to examine the type of the message variable. Now if you hold down the Option Alt key on a Mac, the cursor will turn into a crosshair. If the crosshair is moved over the name of a value, it will turn into a question mark. Clicking on the value name while the cursor is a question mark will bring up this information pop-up, and it will tell us that message is still typed as a string. As further proof, I'm going to come down here and I'm going to try to set message to an integer value after it has been initialized as a string. And Xcode is going to give me another error marker. If I click on it, we'll see that it's going to tell me that I cannot assign a value of type int to a value of type string. I'm going to remove the offending code here and turn to the other type of value in Swift, which is a constant. A constant is declared and initialized just like a variable, except that instead of using the var keyword, we use the let keyword. So I can write let and then the name of the constant, which I'll call pi in this case, and then I'll initialize it with 3.14, letting Swift infer its type. So if I hold down Option Alt again and click on pi, we can see that it is of type double. Now I could have explicitly declared pi to be a double, and in some cases that's necessary, but in this case type inference will give us much cleaner code. If I try to change pi to a more accurate value of 3.14159, Xcode is going to toss another error marker for us to look at. So if I click on it, it will say that you cannot assign to the value pi because it's a let constant. However, in this case, there is a fix to make this code legal, and Xcode has told us what it is. We can simply change the let to a var. And if we want Xcode to make that change, I can just double click on the fix and the error goes away. One more thing to note about constants. It's possible with constants and also with variables to declare them on one statement and then initialize them later. Now it may seem that this may seem odd with constants because you can't change the value of a constant, but initializing it is different than changing it. So you are allowed to initialize it once, or at least initialize a constant once, but after that you cannot change it. So now this code is still legal. However, if I attempt to change it again, it's going to give me this same error that we saw last time. Now that's almost all there is that we need to know about the basics of variables and constants, but there are a couple of more details that we need to cover first. So I'm going to delete this error, and what we'll do is we'll talk about first that the type of a value must either be declared or inferred when that value is created. In other words, the value declaration must use either a type annotation, be initialized with a value in the same statement, or both. So if I were to say var hello and then just give it a type annotation, this is okay. If I were to remove the type annotation and initialize it with a value, that's okay because we can infer the type. And obviously it's okay to do both and be very explicit. Now what I cannot do is I cannot try to declare a variable or a constant without either initializing it or giving it a type annotation. Xcode doesn't like that. It's going to give me an error. And if I click on the error, it's going to tell me that the type annotation is missing. So remember earlier when I said that sometimes a type inference is not an option? Let's take a look at an example of when that might be the case. So suppose that you have a value that will increment or decrement in intervals of 0.1. Now that would obviously be a double. But what if we want to set the initial value to 10? So I could say something like var setting, and since we want this value to change, increment and decrement, we will make it a variable, and I'll set it to 10. Everything looks okay so far, so now let's try to increment it. So I'll say setting equals setting plus 0.01, and I'm going to get an error. And that error is because setting is assumed to be an int, but we're trying to add a double to it. So what I would have to do in this case is I would have to explicitly declare setting to be a double, and now the code works. If I wanted to make this code work without the type annotation, then what I could do is delete the type annotation and initialize setting to be 10.0, and that would also tell Swift that it should be a double.